Okay, in this we'll start with graph theory. Graph theory. Okay, in this actually graph theory is a study in which we'll replace a basic network with simple lines. Okay, and study the property of that network. Okay, the making a graph of a network is very simple. There are few rules which you have to follow. Okay, first we'll try to make a graph of a network. Okay, means how to make a graph of a network. And there's all the elements in a there are, means there are few points which you should know before making a graph. Every element in a network is replaced by a line or arc, or you can say semicircle, right? Will replace elements of network with a line, arc, or a semicircle. Voltage source is replaced by a short circuit, and current source is replaced as open circuit, right? This we have to remember. This is in line with that the voltage source has internal impedance of ideal voltage source should have an internal impedance of 0 ohms, and ideal current source should have an internal impedance of infinite yeah, infinity. Okay, so this is in line with this voltage source is in line with replacement is in line with the basic rules. Okay, so let's try to make a very basic network first. Okay, say I have a network like this. I have voltage source here. Okay, one more resistance. Okay, say I have a network like this. To make a graph of this network, first of all, the step one is you should mark the nodes of this network, that are A, this is B, this is C, and this is D. Okay, now taking these nodes into reference, say this is my node A, this is my node B, this is my node C. Okay, and this is my node D. Now we have voltage source in between A and D, right? And it is replaced by a short circuit. So this is with D. We have element resistance between B and D. It is replaced by a line. C and D, it is replaced by a line. A and B resistance is there, replaced by a line. And B and C resistance is there, it is replaced by a line. Okay, A and C also resistance is there, which is replaced by a line. Okay, so this is my basic graph, very easy to form. We just have to find out how many nodes are there, and then we can make the graph. Okay, now moving further. Now in this, one thing to take into mind, which we should consider, the number of nodes in the network as well as graph will remain same, but the of branches in network can be greater than or equal to number of branches in graph. Okay, so as we replace current source by a open circuit, that means we will get, if there is a current source present in this network, that means we have to mean denote it by open circuit. That means we will get less branches in graph as compared to that in network. Okay, so moving further, we'll make incidence matrix for this. Okay, now this graph is called as uh, known oriented graph. Known oriented graph. Why it is called as non-oriented? Because this in this we have not mentioned the direction of current flow. Let's say if I random if I mention the direction of current flow like this, see I have a current flow like this, say this, so this is my uh, I've just assumed the current flow to be like this. Okay, now with this current flow direction will draw the augmented. Now the graph has become now the graph has become oriented graph. So this we can cut. So now the graph has become oriented graph because we have mentioned the direction of current flow. Okay, after that uh, we'll make augmented incidence matrix. It is generally denoted as a a. Okay, in this we have to okay, in this we have to mention the nodes. There are four nodes: a, b, c and d. How many branches are there? That will define the branches as well. 1, 2, 3, 4, 5 and 6. Okay, so we'll mention the branches as well here: 1, 2, 3, 4, 5 and 6. Okay, let's make the matrix out of them. Now making a matrix is very simple. Take a node A. Now A is that A node has three branches connected to it: 1, 2 and 6. We have to, in this matrix we will take it as a in this we will show the current direction. Okay, say the we'll take it as a unity matrix. Okay, all the will denote all the values as 1. The main purpose of this matrix is to show the direction here. Okay, so let's say this is my node A. Okay, from branch 1 the current is entering into the node, so we'll take it as, say, I do it in some different color, say red. Okay, so if the current is entering into the matrix, so it is positive 1. Okay, for the node 2 it is current is leaving, so it is negative 1. For the the branch 6 the current is again entering, so it comes out to positive 1. Okay, for the node B, from 2 it is entering and 3 and 4 are leaving. For 2 it is entering, that is positive, and 3 and 4 is negative, leaving. For node C it is 4 is entering and 5 and 6 are leaving. 4 is entering and 5 and 6 are leaving. Okay, and for the D, for the last node, this is 1 is leaving, 4 is entering and 5 is entering. 1 is leaving, 4 is entering, sorry, 3 is entering and 5 is entering, right? Okay, now we'll come out to be a result comes out to be very interesting. You can see the sum of every column that comes out to be 0. Okay, actually in a column we show the uh, current flowing through a branch. Okay, if current entering in row branch is, say, positive x value, and that means the current that will leave the branch is also the, that value only. Okay, so if we algebraically sum the two values, result will be 0 only. Okay, now this is my augmented incidence matrix. Now there is one more matrix called as incidence matrix. Okay, incidence matrix, that is denoted as A only. Okay, augmented incidence matrix is denoted as A, or incidence matrix is denoted as E only, or in general terms we also call it as reduced incidence matrix. Okay, because we reduce a row from this augmented incidence matrix to form this incidence matrix. In this uh, okay, in this matrix will not define this reference node. Okay, reference node is not defined, means node is defined but we don't mark it in the matrix. This is a matrix. What we get is called as reduced incidence matrix. Okay, now moving further, we'll define some basic terms used in a graph theory. We'll define some basic terms such as tree. Okay, now what is a tree? Tree is a connected subgraph. Okay, now we have a graph like this. Okay, now tree is a connected subgraph that will connect all the nodes. The tree will connect all the nodes, right? Tree will connect all the nodes, but it should not contain any closed path. See, if I draw a network like this, the graph like this. Okay, so these branches are 1, 3 and 5. 1, 3 and 5, right? So it it touches all the nodes A, B, C and D. Okay, it touches all the nodes but it doesn't contain any closed loop. So my tree here is 1, 3 and 5. Okay, this can be there can be many combinations. There are many combinations possible for a tree, but the thing we should remember is that incidence matrix for a network is unique. Okay, but tree can be many. How many number of trees are possible for a network that can be calculated, then can be okay, we'll calculate it after defining cotree. Okay, what is cotree? Cotree is the set of branches which are disconnected to form a tree. In this case, we have removed these branches 2, 4 and 6. Okay, we've removed these branches 2, 4 and 6 to form a tree. So cotree is 2, 4 and 6. And as tree is concerned, okay, if the possibility for a tree are many, that means the possibility of coteries are also many. Okay, now the branches of a tree are generally denoted with a thick line, and the branches of a cotree are denoted by a dashed line. And second thing to be that remembered is that branches of tree, these branches are called as twigs. Twigs, TWIGS, twigs. And these branches, the branches of a cotree are called as links. Okay, okay. Now I'll discuss the possibility which generally came into the competitive exam is total number of trees possible. Given as determinant of E transpose. This is the general formula for calculating the uh, number of possible trees. But in for very we can calculate it in an easy way, but there are some conditions attached to it, and that are, see, the form we can calculate this possible number of possible trees by a formula, simple formula, rather simple formula than determinants of two matrices, combined matrices. Okay, the formula is given as n raised to power n minus 2, where n is number of nodes. Okay, Now there are two conditions to this. First of all, that should we can apply this formula only when the two conditions. So the first one is when all the nodes all the nodes are connected to each other. Okay, see, I have a network like this. See, we'll define some graph like this. Okay, and I have node A, B, C, and D. Okay, and this A and C nodes are not connected to each other. They are connected through B. All the nodes are connected, should be connected directly to each other to apply this formula. And the second conditions, these are the two conditions which must fulfill so that we can apply this formula. Okay, and the second condition is no repeated branch should be present. Say by chance the network is like this. Now my first condition is okay, this is okay. Okay, say and so we have to look for there is one more branch that is connected from A to D. Okay, now no repeated branches. Okay, now my second condition is not satisfied as E and D has two branches in parallel. You can say there are two same branch, there are two branches, different branches connected with the same nodes. Okay, so we can't apply this formula in that case. So to apply this formula we have to check for two nodes. Okay, we have to check for two conditions. Okay, moving further, now the question can come like this: total number of possible node pair voltages. Okay, very simple. Okay, we know that to form a potential difference there should be 2 points. Okay, 2 points should be present. Okay, so the voltage can be present between two nodes. It comes out to a simple permutation combination problem, NC2. Okay, this comes out to be NC2, or you can call it as n minus 1 by 2. Okay, this is simple. And in the last the example we have taken in starting of this video, the number of nodes are 4. Okay, so number of these pair voltage possible are, this is 4 minus 1 by 2, that comes out to be 6. Okay, that's all in the graph theory which is possible. Okay, in the next video we'll learn how to make a tie set matrix and cut set matrix. Okay, thank you.